if the conversation is around how software constructs are getting commoditized, etc., right? There's a lot of things that you can look at, and something around, let's for example, Wadley mapping. Simon Wadley talks about what happens to higher order services when things go commodity. So he talked about the fact that when there are layers, when something becomes commoditized, a utility, right? A lot of things that you buy as products and rental services sort of disappear in a very different fashion. There's a lot of stuff in that space. You guys should really look at it. But what I'm going to be talking about today is a very different twist to innovation at Amazon. Right? It's a sort of a technical talk, but sort of a story as well. And what I'm going to do is I'm going to talk about how Amazon innovates when we make a code change. I mean, that's a real hard ground reality. Rubber hits the road at a point where I want a feature to be built, or I have an idea, or I have a hypothesis, I want to take it to production. Right? We can talk about culture, blah, 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 etc., but what happens on the ground scenes, right? That's literally what I'm going to be talking about. And it still doesn't do. Why don't you change to the next slide? Why do you care? We are all sitting here. Next slide. All right. Most people, when they look at Amazon, right, they somehow have this belief that we have some magic potion, some magic construct or something that we do inside this organization that enables us to build these interesting products, technology, etc., I can absolutely guarantee to you, very ordinary people like myself, I mean, the first thing, let me put it, if I am able to innovate at Amazon, anybody on the planet can. Right? It's literally straightforward and simple. We have a lot of good engineers. We hire good engineers, people who have a sense of ownership. Right? They say, hey, I want to do something. I want to create something. I want to build something. That's pretty much it. In our interview process, we don't go and hire somebody says, hey, we don't give like this horrible 300-line piece of code that you have to write on a whiteboard. Nothing of that sort happens. We hire people who can exhibit a set of traits, and the best place to look at what traits we look for is go to this website called amazon.jobs/principles. Amazon Jobs is a hiring site, /principles will get you to a URL where it tells you is that what is it that Amazon looks for in a person. And across every role, people are hired under those. No whiteboarding of programming code, right? But then how is it that you're able to innovate across? I mean, here is a quick pop question. Name the businesses of Amazon. Quickly. Everybody knows retail, cloud. What else? Shipping. Fantastic. Excellent. Next. We do have large ships that run around the world. We also have aircrafts, about 13 of them flying around shipping stuff. That's transportation services, prime air services, etc. We are in the drone business. Continue. Real estate, not that I know of. We are not in that business. We do buy a lot of real estate or use real estate, that's different. But we are not in that, we don't sell it to others or rent it to others yet. I use the word yet every time. Mechanical Turks, that's human labor, fantastic. I mean, other businesses, I mean, I'm sure you have devices, hardware like Echo device, Kindle, Fire TV stick, etc. I'm sure you are used to Amazon Videos, which is Prime Videos in some countries, Amazon Videos in some countries, which is basically our video distribution business, etc. How many of you are familiar with Amazon Studios? Amazon Studios makes movies and television episodes, etc. We actually have 4 Oscars and 13 Emmy Awards, right? And we are in the nomination for this year as well, right? So as a production house, we have these capabilities. Now I can go on and on. We have Go stores. We are on the retail front. We have Amazon bookstores. Remember, Amazon has bookstores, not online, physical format. We have 4-star stores. We have Amazon Go stores, just grocery. We own Whole Foods now. So if you look at it across different kinds of businesses, different class of businesses, robotics, etc., we innovate across these boundaries in a number of different businesses wherever we are able to do and influence in a very customer obsessed manner, where we see their ability to do that. And the way we do that is we bring in technology to bear and innovate very, very rapidly in these spaces, right? And that is how we do it. But the way we do it, how does that happen? There's no unicorn in there. And many of them think that, somehow we are able to hire 10 of these individuals, do some magic, something will happen. It won't happen, right? I'm going to show you what happens behind the scenes. Next slide, please. Right. So what is it that we do in the technology to bear? If you look at it, within Amazon, I mean, these numbers are actually a little old because the slide deck is a little bit old. We do about 50 million deployments a year to production. That's the rate of velocity of how we take something to production. 50 million is an old number, it's about 3 years old. We do north of 50 million is the number I should say today. We have tens of thousands of builders, and it's sort of like less than a second. So practically, if you are experiencing Amazon today, there is a delta change somewhere in the world today right now that's happening less than a second. Something is changing and improving constantly. That's how we take something to production. It's happening continuously, and it's important for us. We innovate at the velocity. What happens in innovation? What is innovation? Innovation is the ability for you to say, hey, I made a change through which I gave customer a better benefit, or I am confirming or rejecting a hypothesis about the business we have. Right? I have an hypothesis that people with right-handed thumb with a mobile phone would click this feedback here versus here. Instead of having a debate between engineer and product manager, we just put it in both places, and then we figure out after 1 million users which one customers would like based on which device and how it is, whereas a 7-inch phone versus 5-inch phone, etc., etc. Maybe in Germany everybody would like to have it here versus in US it will be here. We don't know. And we would like to validate the hypothesis. That could be a production release. We put it out there, 3 months later we roll it back out because we have validated the hypothesis, right? That's what we do. Right. So much of what we enable at Amazon, right, is our tooling. How does this happen? Is that we allow developers to use the tooling. There is a lot of internal tooling we do, and the good part is that a lot of the internal tooling that we have, through which we have been doing software releases, technology change, innovation, etc., is actually available to you all. It's not that we have kept it in-house, because at Amazon we have a very interesting philosophy. If it's good for us, we want to externalize it. Why? Because if you are able to do something better with that, that means we are doing something right. Think about AWS. We did IT in a particular way internally for 10 years, right? In 2005 and 6, there's a simple question. Why do you think this is the right way to do IT? Okay? Let's package it and give it to people outside. If they think it's good for them, then it's good for us. Correct? The greatest of innovations are things on which, right, others can realize your dreams, their dreams. If you build something and somebody is able to innovate on top of you and do something much better, what you did is actually one of the greatest innovations. Think about it that way. But if others are not able to build their dreams, realize their dreams by building something on top, you have to go back and question what you're doing. You have to say, hey, you know what, there's probably better technology, and you have to build that culture around it, and that's what we do. So we take our tooling and fabric, whether it's AWS, you take anything else, right, our digital innovation fabric, if you look at how we offer video synthesis services, media streaming services, etc., that we offer, is offered to people, other customers who build on top of us. So many times I keep getting asked this question, hey, why is it other retailers or media companies, you have Netflix running on you, Hulu running on you, HBO running on you, you have Hotstar running on you, and you also have Amazon Prime. All runs on Amazon. Right? You have a number of retailers who run on Amazon. Absolutely. And we keep them as completely separate businesses, and we make everyone as successful as necessary. Urban Armor runs on us, right? Next one, please. Thank you. So the rest of the talk, I'm going to focus on this process of a code change. We're going to go into the technical and cultural landscape, and then we'll go through the rest of the stuff. Next one. So how does the Amazon culture look like? There's a cultural formula, but this is our business model. You can look this up on Google. This is something Jeff Bezos documented long ago. It is as scrappy as on a piece of paper. We don't do any sophisticated tooling. Generally, you can do everything in Amazon on a piece of paper, on pencil. No special software required. TextPad, Notepad works brilliantly to innovate. That's how we think about it. The idea is you should be able to build $1 billion business with $10 of tooling. Good idea, right? So what's the, hold on. Alright, so how does this work? At the heart of it is customer experience. If you build good customer experience, we want to build that. We are customer obsessed, we want to build good customer experience. If you build good customer experience, there is traffic to you. Traffic is basically customers want to come to you and say, hey, I would like to use your services the way you deliver it to me, whether it's online, offline, whatever. There is traffic that you build because your experience is good. When the traffic comes in, you have to empower the traffic. You have to say, given this traffic, I'm going to have people come and sell products to them. Sellers are interested because there is traffic. Once you have sellers increase your selection. And as selection goes up, customer experience improves. You can create this as a cycle. Now, if you run through this cycle enough number of times, something even more interesting happens. You start growing, and as you grow, you get into economies of scale, which means you can lower prices. And when you lower prices, your customer experience improves. Have you ever thought of a situation where you go to a customer, I would like to raise your price now? What would the customer say? No. There is one thing you can take for granted in this world, absolutely for granted. No customer wants to pay you more than what they were paying before. They don't want to. You may ask them for it. So, we take that as a standing guarantee that we will not raise prices on someone unless otherwise we absolutely have to. We have done raising prices occasionally, right? Amazon Prime is an example, and we know where we have done it. We tell customers this is the reason we are raising price, but we raise price because we increase the selection substantially. Look at the selection that's been offered when Prime increased, right? But if you look at AWS, we have reduced prices 68 times. Right? And if you look at any of the number of selections, we have reduced prices. That's our flywheel, and we do this across businesses, not just one. Right? Next one. And our innovation equation is this. Innovation is powered by mechanisms and architecture, powered by culture and organization. Mechanisms is basically another word for process. Right? The reason we use the word mechanism is culturally in our head it goes like this. When you use the word process, people say we should not violate it. Right? If you use the word mechanism, people say, okay, what other ways can I do it? Because is there another mechanics to do it? The belief in our system is that if there is a process, we start with the statement, until you know better, do this way. All of our documents, mechanism documents, process documents have this prefix. It says, until you know better, do it this way. When you know something better, just do it the other way, right? And share it with others. So, every process is questionable. This formula is questionable. Right? Next slide, please. All right. So, deep inside, we are a service-oriented architecture. I mean, as an organization, we raise tickets. So, when Ganesh wanted to get me, he practically raises a ticket on me, saying, Madhu, I need you to come and talk at this event. Right? And I fulfill by closing the ticket. Inside the company, we do that. Why do we do that? Because when he raises a ticket on me, I know how many requests come to me. Right? Over time, like Shamik said, eventually I can create an AI plus myself service. Right? And I can fulfill an automatic slide that will go and deliver somewhere with Amazon Poly and Amazon Sumerian as an outcome. Maybe not today, maybe not tomorrow, but maybe in 3 years. If there is enough requests that he is raising, let's say 400, I can still deliver it as 400, right? That is presentation as a service. Correct? It's possible. So, everything is service-oriented architecture inside our organization for us. Next slide, please. Yeah. And the way we construct ourselves, in spite of the fact tens of thousands of engineers, is there are only 8 to 12 people in a team. We call this 2 pizza teams. You must have heard of this, number of blog posts, a lot of people have written about it. What is a 2 pizza team? It's effectively a team that completely has ownership on an outcome that they will deliver. That can be sit in a room or sit wherever remotely, whatever, but you can feed them with 2 large pizzas, American pizzas. That's all it is. That's our team construct. And that team completely owns the outcome, nobody else. If they say, hey, this service is not there, I need someone else to deliver something to me, sorry, your responsibility to deliver your outcome. Now, as part of delivering the outcome, you may create additional sub pieces that's required, somebody else may pick it up and run with it, another 2 pizza team. How many 2 pizza teams we have in Amazon? Thousands. Next slide, please. Right. So, that means I think you may need to go one more. That's it. So, what ends up happening as a result of that is when you do that, up top at the senior management level, what you are seeing is you see 2 pizza teams. Look at any startup, they are effectively a 2 pizza team, 1, 2 or 3 of them, correct? So, we are a federation of startups inside the company, thousands of startups running and firing, solving very specific small problems that can scale over time. It may be a small key value store. Have you heard of DynamoDB today? Have you heard of MySQL being engineered a little bit differently on storage? It started that way. What is it? Aurora MySQL today. Have you thought about virtualizing infrastructure very differently in South Africa? Right? 2004, a couple of engineers sat together and said, let's virtualize infrastructure so that we can service people differently. Became EC2. Not bad, right? So we solve this starting as two pizza teams. A federation of startups, everyone owns the product end to end. Next slide. And then we build them as services. Break up the monoliths, build them as services, and as you build them as services, next slide. What happens is there is a lot of dependency, sub-dependency built across services. Even if you look at services like EC2, like S3, like any of the AWS services that you use, like SageMaker, for example, it is not just SageMaker, that's how you see it as consumption. But if you look below SageMaker, they leverage services from S3, they leverage services of EC2, they don't rebuild all that. They just cross-pollinate and say, hey, here is a ready service I'm going to use and I can do it. And every small team has an ability to pick up and leverage somebody else's service. They have more than one choice. How many different services are there to message inside AWS? There are 7 of them. There is SNS, SQS, Managed MQ, Pinpoint. Think about it. There are enough. There are 7 different services. How many database services do we have? 8 at the last count I did. It's not one database. We don't say we are going to standardize an Amazon across one database. No, we don't do that. You can choose what you want to do. Right? Continue. So almost everything is a service. Next. Right? And they become manageable components. Remember, each circle now is a manageable component powered by a 2 pizza team. Right? And the singular focus of the team is to improve that service. Let's say we have one of those bubbles out there that needs to be changed. There is a better version of that. The consumers will change and that service is retired and there is a newer service coming out there. Next slide. So let's meet our hero, the change. This is the change we want to do. One of those microservices out of the millions that we have is going to get changed. Right? And what happens? So that's the hero of the problem and this hero is going to go through a journey. It says hello world and we want to change. Next slide. We are a wild west. So we do yeehaw. What does that mean? The developer who has the idea to make the change is allowed to go ahead and make the change with no approvals. That's our culture. You can make the change. You don't have to ask permission from anyone. You have an idea to make a change? Go ahead, do it. Where do? You do it on your laptop. Are we, the classic question that comes up, are we agile? Do we do DevOps? Do we do SDLC? We don't know. We don't care. Why? Because everything works. If you're trying to solve, let's say, a search engine problem, you can't solve it agile-ish. You have to do a much more structured SDLC process, like a waterfall. If you're trying to build a business service for billing, you can do agile-ish. You can do other things. But the ownership is with you. So you can take whichever you want. The idea is, as soon as you create the new service or a change to your service, the confidence we have is the process is going to take care of you and it won't allow you to cut corners and then you are allowed to iterate. Your laptop or your desktop on your desk is a production host as far as you can mentally think about. The way you do it is you make your code change, you host your change in your machine or on your hosted AWS environment, your own, the developer's own environment, and you do a service fabric app mesh switchover. You basically say, hey, for these test cases, route that request through me, for others continue wherever it goes in production. That's the beauty of microservices architecture, right? You can choose which packets get routed to you. Requests get routed to you. That change will come to you and then your service now provides the improved service. You can measure it, you can validate it, you can do any number of testing and all of that's happening in your personal host. That means you have built it, you have validated, your idea sounds very interesting. You can now take data and show it to your manager or anyone and say, hey, I tried this, this seems to work. So any engineer, if they want to try an idea, perfectly open to do so. Next slide. Tooling philosophy. So the next thing that comes up is, next slide. How do they build this? How do developers think about building? You only focus on your outcomes and you can use any tool that's available in the Amazon ecosystem. So let's take some simple examples. Let's take JIT. Do we use JIT? Absolutely we use JIT. But one of the things that we really wanted to make sure is we want developers to be able to share information, code information. So we take JIT and we create JIT farm. What is JIT farm? Something very similar to JIT but in our own way unique. We modified it. We allow you to search source code across the company. Every developer can search the source code across the company. They can find out what's there, how it is there, how somebody has built it. So if there is some service that you want to use and you want to know how to use it, you don't have to call another person, you don't have to search for documentation, you just use JIT. Search the code, look at how others have consumed it and then use it yourself. Highly self-service. Second thing is, all the services are available as a marketplace internally. It's an internal marketplace of services. Remember, if you're doing 50 million deployments, there are probably a little over a few million services out there. Right? So, all the services are available as a marketplace for developers to evaluate what to do and how to do. And then, one of the key things that we do, think about it, let's say this is one team, 2 pizza team, there's another team. It so happens one of the developers here has decided to build something new. And at the same time in this team, he has also decided to build something and they both are building duplicates of each other. We perfectly encourage that. Right? We don't stop them. We don't stop them early. We allow them to evolve. And once something has scaled sufficiently internally, we fund winners. So we say, hey, your service that you're building, let's say he did a good job, we say service that you're building is great, but your team is focusing on another outcome. So we're going to spin off that work to another 2 pizza team out there, which you can lead. And then this team gets another person. Right? Each of these services independently scale, and that's what we mean by funding winners. And some of these services bubble up large enough, they actually become AWS services. Like DynamoDB, like EC2, like VPCs, like WorkLink, right? Because we have used them internally and scaled them sufficiently large internally. If you use our AI services like recognition for object detection, how does it work? Simply because we started building object detection services in our warehouse to identify that the right item is being shipped to you. Why would we build recognition video? Because that is the same service that we built fundamentally from Kinesis video streams to recognition video so that the Go store can detect what activity is happening inside the store. Right? So everything that we do in our services, you have in another shape or form. Next slide. So, if you have a hero, we must have a villain. That's the process, the release process. So, the release process is the villain. It says, I am going to make the check and balance great, fantastic, you are innovating, you are moving fast. I am going to slow you down. Jeff Bezos calls himself the chief slowdown officer. Because if you're running too fast, then there could be other issues, right? So, he calls himself the chief slowdown officer. Next slide. So, the change is seen as the villain by the process. The person I don't want to be. You're evil, you're difficult, you're hard. I want to look at you very differently. Next slide. So, change is born and then we bring our tooling. The tooling is JIT, replication, access control, code search, etc. All of the tooling that is necessary for a developer to be able to build the service as efficiently as possible, to bring about the code, host it on a service, do the network packet routing. That's the cool. All of them are simple services that we have that enables the developer to do that. Next slide. Then we enter the finished product and we enter the code review. Code review and does this change, I mean when you look at it, the change looks small, it's a microservice, but when we start looking at it from a standpoint, right, the change will not look simple. And we're going to put that to a review process, and this is where the manual intervention comes in. We do code reviews, there's automated reviews and there are manual reviews, but the manual reviews are very, very critical to us. Depending on the kind of service that is being written, we have 2 people minimum do the review. This could be 2 engineers who are doing code review, or there would be a senior engineer. For our tier 1 service, we have a senior engineer, which is typically classified as principal engineers or senior principal engineers in Amazon, who would actually review your code. Reviewing your code is not about saying, hey, your code works. Reviewing your code is about actually reading your code and saying, have you looked at this? Have you looked at the boundary conditions? Have you looked at what happens? Reviewing is not about checkboxing something. And there's principal engineers and senior principal engineers have a major duty. They don't write a lot of code. They do a lot of code review. And the second thing they do is when we have an issue, they have to write a document called a COE. A COE is called a correction of errors. And the COE document is something that you have to write every time an issue occurs. S3 reduced availability, February 2017. For about 3 hours, S3 goes like this. Worldwide impact, right? The COE document is about 70 pages. You have to write it. So, for every single issue, we don't blame the person, but we blame the process. We say, hey, you know what, the code review probably didn't work right, we got to fix it. You know what, the release process probably didn't work right, we have to fix it. The way we validated the tooling didn't work right, so we have to fix it. We ask 5 whys. Error, why. By the time you get to the 5th why, new answers evolve. Try it, it's actually very simple. Ask somebody why. The first answer is typically finger pointing. The second answer is next level of finger pointing. But the third answer is harder. It typically points to something that you do. The fourth answer is somewhere else. And the fifth answer gets to something really complex, something deep down in the cultural fabric, in the process fabric, in the nature of how your organization thinks and behaves every single day. And generally it points upwards. We go fix that. Because when you fix that, there is a scalability advantage. It will fix 100 things below. If you fix only this problem, like this developer is no good, you would have fixed that issue, not the next issue. Think about it, if you're going to deliver a service that is going to be used by millions of consumers, you have to fix real root cause issues. Next slide. So then we enter the build process. The build process is of course a 4-step process. Very important, we do global dependency closures. This is for the technical guys though. The global dependency closures, that means what happens is if your service is using other services and other services are using you, all of that is compiled in your build environment. The whole thing. If you are building a library, we cross compile every single thing like S2N, SSL library. We cross compile everything and all your dependencies are validated and checked. It's cheap, right? I mean, think about it. If you're on the cloud, the advantage is I can go ahead and dynamically create a build environment, run the whole thing and then shut it off. It may take 45 minutes or 2 hours or 3 hours, but it's okay, it's cheaper. So we do global dependency closures end to end on what we do. Next one, then we do unit testing. Every developer should write unit testing, hard unit testing cases. It's one of the whys. In the failure, if you see a unit test case is not written, flag it. Then static analysis. Making sure that the code is secure, safe. The code is completely validated against all the statics that we are using, where data is going, how it's moving, etc. And finally, of course, we have global and-on cards. Bad software is blocked. So somewhere in our process, we support the fact that when software is poor, you have the ability to pull and roll back the software. I'll talk about it when I get to the release process. So, and then we do a pre-mortem. A pre-mortem is a meeting. A developer who has finished that work, you have finished that work, you sit in a room with others, with your code review, with your global dependency closures and you do a review. This is a whiteboard review of the process. Done. Your code change is good and your code is about to go. Pipeline and deployment. This is where we go. And in the pre-mortem, there is something that we do which I'll talk about next. Test, integration and go to production. The change actually looks at it and says, wow, this looks like a long journey. Yes, it is going to be a long journey because the journey looks like, actually you can go one more slide. I will not talk about this. The journey looks like that. That's our release management process. Oh, by the way, it's only 70%. There is another 30% on that side. It's huge. But everything is a simple check and balance. A very simple checks and balance. They are all based on primitives. Think about what is a release? Oh, I have to do code review. Oh, it has to check with that. Oh, somebody has to validate that this is good to go. Somebody has to do something manually, somebody has to do something automatically. Any of these steps here can be automated. Any of these steps here can be manual. You get to choose. You get to choose which is manual, which is automated. Let's say for example, I want to do a global deployment of a service. I'm going to make a change to the way S3 behaves and I'm going to put a change through. Now, how many places do I have to deploy an S3 code change? There are 20 regions, 60 availability zones and few 100,000 servers. That code change has to go few 100,000 servers. That is what it has to hit and I have to do this release. How do you do the release? Think about it. So I could say I'm going to deploy it in US East 1 on a set of servers for a set of accounts and try it. 3 hours into that and 50% of the, 99.9999% of the cases are successful. I'm going to expand it to other accounts in US East 1. And then I'm going to do it to US East 2 and then US West 1, US West 2, so on and so forth, and I keep expanding progressively. and then do a global rollout automatically. And I can use data and numbers across the board to say when these gates are hit by data, automatically you keep rolling forward. And when there is a problem, roll back. Or I could have manual intervention set up that says every time it goes to a new region, I want manually somebody to approve it. You choose how you want to do that as a team, your 2-pizza team, not someone else. Your 2-pizza team decides whether it's a global rollout, region rollout, zonal rollout, customer specific rollout, patch rollout, your choice. And you have the control plane to do that. So what are the release primitives? Manual approvals. Next slide. Time windows. Deploy something and wait for some time. 3 hours before you roll out to the next step. So we have time window functions. Remember, think about how primitive it looks. It's a simple time window function, but you can pipeline them. Next function. Test tasks. Insert tests into your release process. It's a simple test task that says, did I succeed 99%? Did I succeed 99.99%? Did I succeed 70%? You can set your gates and choose how to do it. These are simple test tasks. Next one, global and-on cards. So let's say something goes down. This is something that I want to talk about is you are perfectly okay for a developer or a team to say that you can do the entire process manually. But there is one process you have to automate that happens in the pre-mortem. One process you have to automate. Do you know what that is? The undo process. Let's say you deploy something to production. The undo of production has to be automated. That's the only process we request, that it will not go to production if you can't automate that. Why is that? Because if something goes to production and fails, we don't have time to call you. We don't have time to call you, because we call you, you wake up, middle of the night, middle of the day, it doesn't matter. Then you get on the phone, log in your laptop, go into VPN, you're losing minutes. And on global scale infrastructure, not a good idea. So we need to be able to say something has failed and on card, roll back. It's like an emergency procedure. We need to be able to stop something. Anybody should be able to stop something saying, hey, that service is not making sense, roll it back and continue back with other services. We should have that ability. That is what gives you operational excellence. So we do global and-on cards that support automatic rollback across our entire pipeline. That is the only thing we expect at a minimum is automated. The rest, you're okay to go. Next one. And attribution and roles. Across the organization, we know who did what. 2-pizza team enables that automatically. So we don't get into this Sev 1 call, 95 people, hey, who did this? And there are 3 calls. I've been through that many times. It doesn't work like that for us, which I was amazed when I saw this here. It's like, yes, 50 people get on the call, but we are not searching for who did what or why. And we never ever, and this is something that I've seen amazingly weird during my experience at Tata Motors and other places. And I used to build Siebel software for 9 years. I was the product engineer, and I did all kinds of weird roles in the company. But I've seen customers get into this shape where we get into this conversation and we ask this question, hey, have you tried this? The guy says, yes, I've tried it. Good. Can you try it again? I mean, if nothing changes and you're doing the same step again, that's practically madness. Can you restart the machine and try again? Like, what are you trying to do? Analyze the log and find out what the root cause is. You just don't, keep pressing enter. Let me see. No, it doesn't work like that. And I've seen a lot of people do that. Don't do that. If you do not know, find somebody who knows. If you don't know, analyze the log. The data is there. I haven't seen people analyze logs as much. So that's attribution roles. We need to know who, what, and where. Next one. And then, of course, this is automatic rollback. I spoke about it. Next slide. Then incremental releases. Progressively allow rollouts. The support to do progressive rollouts is available as a tooling fabric that says, I want to go, machine by machine, cell by cell, zone by zone, region by region. How do you want to do the rollouts? Right? We support that as an incremental release favor. Next one. Health tracking. Continuously as you run, you have health tracking available for you to run. Look at the primitives now. We are looking at primitives that are much more simpler. I want health tracking capability. We all do this. We do logging. I've seen companies that say in production we don't do logging. It's actually exact antithesis of your problem. You should do logging in production. Yes, you will have performance issues. Why? Because your hard disk is being written more? Yes, it will, but write your log somewhere else. But logging is your analysis. Logging is the proof of what's going on. You can't log after your problem. You have to log before your problem. You know how much we log? Anybody, any guesses? Take a guess. How much does just AWS, forget Amazon. How much do we log? Correct, but how much for an hour? 1 hour of AWS, what's the log size? 48 terabytes. 1 hour is 48 terabytes for us. We log this. Why do we log it? Because we have to know. We store data guilt free. Then you say we are a data giant. You have to store data guilt free for to be a data giant. You have to understand what it is. Then you remove the noise. But you have to first store it. You have to analyze it. Then you remove the noise. Right? So health tracking. Then we figure out what is failing, what's succeeding, how it's going, green, blue, red goes fail, take it out, rotate it. We have the ability to automate that, right? Monitor that. Next one. Change providence, of course. What changed, who changed it, why did it change, the whole underlying principles behind it. Yeah, move on, tuck. Of course, security, very important. So, that change basically looks at auto rollback, health tracking, process change providence, incremental releases as tooling, and it's very happy to take it forward. Next slide. Right? So the thing is, this construct makes the change untrusted. But remember, it should be untrusted, right? The change that worked brilliantly should be untrusted by the process, but trusted by the developer. Move on from there. So then managing infrastructure and auditing. Put that to production, put it out there, it moves forward, one day region build. So today we have the sophistication to do an entire region build. So you want S3 deployed in a single region with a new feature, a new code change, boom, it's possible. At reInvent, we make an announcement, Andy Jassy gets on stage and he says, hey, S3 has this feature, 5 minutes later it's worldwide available. Because we know how to push it, right? He says it's available 3 weeks from now, we release a blog, boom, it's available. We wanted to run Prime Day, we have the ability to scale it for that day. It's not easy. I mean, if you step back and think about it, what is the hardest thing of running a Prime Day? It's not code. It's not hardware. Actually, we are a cloud provider, so hardware can scale. What is the hardest thing? How do you know what you will order? I still have to fulfill it in 2 days. So I have to predict every potential order and fulfillment need to be in our warehouses fully stocked and ready, so that when you place the order, we know what to ship. That's the hard part of Prime Day. Right? So building for that. So you think about it, whether it's machine learning, whether it's software code, whether it's everything is fulfillment at the end of the day for us. Right? So the ability to scale that, build that, set that up is where the challenge comes from. For us, that's a change request. How are we going to design for that and how are we going to put that in there? Right? And then lock in your best practices around templating engine. Next slide. Finally, the code makes it, production change in play, and then we are good to go. The code change is done, the developer is done at that point, but the team is not done because the process continues. The process says, I'm going to audit and I'm going to assess risk of this change that you put out there continuously, non-stop, because problems that does not occur at 50,000 concurrent users may surface at 5 million. Things that don't surface at 5 million may surface at 50 million. Problems that don't surface on a certain kind of infrastructure in US East 1 may surface in BOM, may surface in Singapore, right? Because you have minor changes in hardware, you have minor changes in the underlying plate, you have control plane changes, etc. And there's changes happening continuously. Global dependency changes can cause changes to occur. So continuously things are audited, monitored, validated at a microservice level for us to know. That's the reason we log 48 terabytes, so that we actually understand what's happening in every service at every level. And it's not just AWS, we do this at Amazon. That's the reason you're able to run a service. I mean, the classic example I ask question, you open your mobile phone, you check, you go to Amazon.in, the page doesn't open. What do you think happened? What is the first reaction you have? Your mobile network is not there, correct? You go to your office, connect, You try to connect your performance management application. It doesn't load. What do you think happened? Mobile network or performance management application? Why do you think the other way? Same exact use case. Why do you think on one case mobile network is down, on the other case your application is down? Because there is a trust that this service probably will not go down. We have been down in the past, but there is an underlying trust that your service will not go down. That is possible because we do this. Continuous monitoring, continuous auditing. Next slide. And then we don't necessarily fully, Amazon standardizes a ton of software development processes, but not on the tooling. We don't tell our developers, all of you must use this editor. All of you must use this compiler. All of you must use this programming language. All of you must use this framework. We don't get into debates about React versus Angular versus, I don't know, there are a bunch of others like that. We don't get into a debate on whether it has to be Spring Boot versus microservices built in Golang. We don't get into a debate on whether you have to use a particular framework in a particular style. No. The process is our template that you saw. The tooling is up to you. We will write in anything that we see is the best way to express that problem. AWS Firecracker was written in Rust. Our console is written in 3 different languages across services. There are many services that are written in Java, many services that are written in Go. There are many services that are written in Python. It is up to the comfort of the developer and the team. If you are in a microservices fabric, it is possible for you to do that, right? And we allow and support that rather than being religious about it. What we are religious about is the process, the release process, the providence that we can bring to it, the control we can bring to it, etc. That's what we look at, and we ship continuously because we know we have built the confidence to do it, right? And this has taken us 24 years. It didn't happen yesterday. It took us 24 years to build this discipline, to do north of 50 million. But my belief is, if you start today, it's viable. And we have the tooling that's necessary for you to take it forward. The tooling is there. You can build the process on top of the tooling. And then you can innovate like Amazon. We don't see that as a challenge. And there are a number of companies that do that, not just us. Thank you. Yeah, I stood between you and lunch anyway, sorry.
One question.
Any questions? Yes?
When you do code dependency user, do you check your dependencies or do you check only your dependencies or do you also check who's dependent on you?
Yes, both.
Okay.
That's global dependency.
In a microservice world, how do you know who's dependent on you?
So for example, think about it. So there are 2 kinds of changes that occur. You are building a brand new microservice which is unconsumed today, which means you have no external consumption or there is no internal consumption. But if there is somebody who is using it today, correct? We know that, and you are only making a code change to an existing, so you are doing a delta like a .100 to a .101 release, right? When that's going to happen, what happens is you basically have your host run out there and have a set of requests route through you. It could be 5%, 10%, specific account numbers, specific account changes, etc. A lot of people think in AWS that, in the SaaS world, there is this fundamental tendency to believe that everybody's instances are the same. That's actually horribly incorrect. That's not true. We can, at an account level, give you a different experience. At an account level. Right? We can actually say for XYZ and customer, this API is going to behave a little differently because we want to improve your experience differently. We can add an additional parameter in there, we can add an additional call in there, and we can build those changes. That's how we improve our services. We add capability to S3 because everything that we build in Amazon, right? 95% of everything we build in Amazon works backward from a customer. There's a customer who comes and says, hey, we want you to do this. So we then work with them, and that's how we build that change, and that's a change. We do the global dependency validation so that their change is not going to break anybody else's change when that goes to production. We do that. And it's automatable. I mean, if you have an automation engine to support the unit testing process, it's fairly straightforward to do that. Sure, thank you.